Let's solve few problems based on vectors. Look at the first one. Find mod of A cross B if A and B are given by this one. Okay, so first what we'll do, we'll calculate what is A cross B. So in the first one, now remember A cross B is what? You have to take the determinant and you have to do it, isn't it? So A cross B is equal to determinant of I, J, K, 2, 1, 3, 3, 5, minus 2. Okay. Now, let's do this one. What do we have? I into, remember, when you take I, take off the row, take off the column. You'll get minus 2, minus 15. So, we have I into minus 2, minus 15. Next, minus J into minus 4, minus 9, plus K into 10, minus 3. So, what do we get? Minus 17I plus 13J plus 7K. Remember, this is A cross B. But what do we want? We want modulus of A cross B, isn't it? So, modulus of this is going to become, so mod of A cross B. This becomes root of minus 17 square plus 13 square plus 7 square. So, which basically is root of 507. So, this becomes modulus of A cross B. Okay, the value, just the magnitude of A cross B becomes root of 507. Fine. See the second one. Find a unit vector perpendicular to each of the vector A plus B and A minus B, where A and B are given by this. Okay, now remember, in cross product, if you calculate the cross product, that is a vector perpendicular to both the given vectors, correct? Now here we have A plus B and A minus B. Calculate. Let's calculate A plus B and A minus B. So here for the second one, first we'll do A plus B. Remember, A is this, B is this. When you add 3i plus I, 4i plus 4j, 2k cancels out when you add them. Next is A minus B. A minus B, 3 minus 1 is 2i, 2j cancels out, 2k minus of minus, this becomes plus 4k. Fair enough? Now what we do, okay, so let's do one thing. Let's call this as vector C. Let's call this as vector D. Now you do vector C cross vector D. I, J, K, 4, 4, 0, 2, 0, 4. Let's do the cross product. I into 16 minus J into 16 plus K into minus 8. 16i minus 16j plus 8k. Now, if you look at this one, what you have is, you have a vector, you have vector A, you have vector B. When you add and when you subtract, you're going to get vector C and vector D. Now, we are looking at a vector which is perpendicular to both vector C as well as vector D. And that vector is given by this one. Alright. But it's not just the vector what they're asking. They are asking you a unit vector. How do you find unit vector? Vector A by mod of A, correct? That means in this case, we have the vector. This is the given vector. Not given vector, the vector what you found out, which is perpendicular to both A plus B and A minus B. Isn't it? So in this case, the unit vector will be equal to, now remember, you have to calculate the modulus of this value, isn't it? Which is root of ax square plus ay square plus az square, correct? Now, this particular vector also you have to calculate the modulus. For this particular problem, it's going to become 16 square plus 8 square, which is 64, which is going to give you 576. And what is root of 576? 24. So you're going to get 1 by 24 into 16i minus 16j plus 8k. Now remember, you can take 8 common. If you take 8 common, I think I might as well write the answer here. Okay, so the unit vector becomes, if you take 8 common, 1 by 3 of 2i, because 16i 2i minus 2j plus k. This becomes the answer for this particular question, the second question. Fine, this is how we calculate the unit vector. Alright, let's do the third one now. See the third one. You have to find lambda and mu if this cross this is equal to 0. Okay. Again, what we'll do, we'll calculate A cross B. So let's assume that this is vector A, say this is vector B. Okay. They're telling you that A cross B is 0, isn't it? Now, you can take it this way. A cross B is equal to 0. 1. Here, vector A and vector B are non-zero parameters. That means angle has to be 0. Correct? Anyway, now first what we'll do, we'll calculate what is this, A cross B value we can calculate. This is one way of doing it. Another way of doing is by taking the angle. So sine theta is what? A cross B by mod of A into mod of B. Correct? Isn't it? Now what we'll do, we'll take mod of A, mod of B. You can start with that also. Or you can just calculate A cross B for now. We'll look into that part. So when we do A cross B, vector A cross vector B, ijk 2, 6, 27, 1 lambda and mu. So this becomes I into 6 mu minus 27 lambda. This is the first case, correct? Minus j into, so when you cross j, 2 mu minus 27 plus k into 2 lambda minus 6. Remember, this value is equal to 0, correct? Individually equate them, because this value, whatever we have, this value, whatever you got, this is equal to 0 vector. That means I 0, 0i, 0j, 0k, isn't it? Since it is 0i, 0j, 0k, what we can write is that 2 mu minus 27 should be equal to 0. That means we are looking at this parameter. That should be equal to 0. So what do we get? Mu is equal to 27 divided by 2. Correct. The next one, what do we have? The k value. 2 lambda minus 6 is equal to 0. So lambda is 6 by 2, which is 3. That means we are taking this value. Fair enough? So we got the value of lambda to be 3 and we got the value of mu to be 27 by 2. This is the answer for the third one. Now let's do the fourth one. See the fourth one. Find the area of the triangle with vertices A, B and C. Correct? Okay, now what we'll do, we'll try to figure out, a small figure you have to write. Very simple figure. Now, what do we have? Let's assume that we have triangle ABC. Now, BA is going to be one vector, BC is going to be one more vector, which are the sides of the triangle, correct? And of course, AC is one more side. Well and good. Now, what we'll do, we'll take BA vector. See, BA vector can be written as OA minus OB, correct? BC vector is OC minus OB. So what will be BA now? So BA vector BA is equal to A value is what? 1, 1, 2 and B value is 2, 3, 5. Correct? Basically, what are we doing? I minus 2I. Correct? I minus 2I. Next one will be J minus 3J. Next is 2K minus 5K. Correct? This is how we do it, isn't it? So I minus 2I is going to give me minus I. Basically, OA is what? I plus J plus 2K minus of 2I plus 3J plus 5K. Remember, this is how we are going to get the value. Okay, I minus 2I is minus I. J minus this is minus 2J. Next 2K minus this one is minus 3K. This is one. The second one is going to be C minus this one, isn't it? What is OC? I plus J, sorry, I plus 5J plus 5K minus 2I minus of 2I plus 3J plus 5K. We got this? So that means here BC is equal to I minus this one. This is going to become minus I. 5J minus this is plus 2J. 5K minus 5K is 0, nothing else. So we got what is BA and we got what is BC. Now to find the area, we just have to do half modulus of BA cross BC, correct? The cross product, take half of the modulus whatever you are going to get and you are going to get the final answer, isn't it? So we'll do the cross product, we'll calculate the modulus and we are going to take half of this. Fair enough? Let's do this problem now. Cross product now. So what do you have? Cross product. So guys, let's call this as A and B, okay? A and B vector. So A cross B is equal to determinant of I, J, K minus 1, minus 2, minus 3, minus 1, 2, 0. Okay. So this becomes I times 0 plus 6 because minus 2, minus 2 into minus 3, right? Minus J into again 0 minus 3 plus K times you get minus 2. Again, minus into minus into minus is minus. 3 minus you will have, correct? Because of 3 minus, you're going to have minus itself. So, minus 2, again minus 2, minus 4. So, this becomes 6I plus 3J minus 4K. Now, this is A cross B. But what do we want? What we want is mod of A cross B. If you do mod of A cross B, you are going to get root of 36 plus 9 plus 16. Correct? Which is going to give us square root of, see, 36 plus 9 plus 16. You are going to get 25 plus 36, just 61. Fine, root of 61. But what we need is half of mod of A cross B. This is equal to half root of 61 unit square, or you can also write it as square units. So this is the answer for the fourth question. Clear? Let's do the fifth one. Fifth one is very similar because fifth one they're asking you area of the parallelogram. Correct? Just the determinant, the cross product, modulus of it. That's it. Okay, let's do the fifth one now. See the fifth one. Vector A, vector B. Correct? Now what do? We are going to just multiply this. Cross product. So cross product I, J, K. 1 minus 1, 3. 2 minus 7, 1. So this becomes I times, what do we get? Minus 1 plus 21. Minus 1 plus 21 gives us 20. minus j into 1 minus 6. 1 minus 6 is minus 5 plus k into minus 7 plus 2. Minus 7 plus 2 gives us minus 5. We got 20i plus 5j minus 5k. Just we have to take the modulus. So what do we get here? Mod of a cross b. Root of 20 square plus 5 square plus minus 5 whole square. Correct? So now when we are trying to do this one, we'll get root of 400 plus 25 plus 25, which is root of 450. Now what we can do, we'll have to, take common. Okay, we can take two things are there. One, you can divide by 9. If you take 9, you're going to get, 9 into 5 is 50. So 450 you will get. You can write 3 root 50. Root 50 can also be written as 5 root 2. Isn't it? So you might as well take 225 common. If not, let's do step by step only. That's also well and good. So the first simplification, what you can do, you can write the same thing as 3 into root of 50, 9 into 50. Then 50 can be written as 5 root 2. So you'll get it as 3 into 5 root 2. So final answer is going to be 15 root 2 square units. This is the final answer. Clear? So the answer for the fifth one is going to be 15 root 2 square units. Fine. Let's finish the last problem now. See the last one. Show that the direction of cosines. See the last one. Show that the direction cosines of a vector equally inclined to the axis OX, OY, OZ plus or minus 1 by root 3, 1 by root 3, 1. Basically, it's the same. Now, a unit vector, see a vector which is inclined towards the axis, all the three axes equally. That means cos alpha is equal to cos beta is equal to cos gamma, correct? This is what it is. So what we can do, we'll calculate what is the value of each, like R value and everything, we'll calculate. Fine. Now, if it has to be equally inclined, alpha, beta, gamma, if all three should be equally inclined, that means it has to be a unit vector, correct? Otherwise, it's not possible. That means the vector is going to be I plus j plus k, isn't it? So what we can write that let the vector be vector A is equal to I plus j plus k. Since we have I plus j plus k, now what do we have? The point is going to be 1 comma 1 comma 1, correct? So that means point A is going to be 1 comma 1 comma 1. Now what is this point? Remember we were writing it as LR comma MR comma NR. So in this case, what we are going to do, calculate mod of A. Mod of A will be root of 1 square plus 1 square plus 1 square, 1 plus 1 plus 1, which is square root of 3. So we got mod of A as square root of 3. But what we are looking at, we are looking at the direction cosine, isn't it? So for the direction cosine, what is the value? It is x divided by r. But what is r? R is nothing but the magnitude of that particular vector. That means here cos of alpha x by r is equal to 1 divided by root 3. And what is cos alpha? L, correct? L is equal to x divided by r. That means we got L as 1 by root 3. Same thing happens with cos beta and cos gamma also, isn't it? But we also have that plus or minus. The plus or minus is because we can have 45-degree in the anti-clockwise, 45-degree in the clockwise. So what do we get here? That because the value of x is 1 and mod of r is basically root 3. R is basically root 3. So what do we get? L is equal to m is equal to n is equal to plus or minus 1 by root 3. And direction cosines is minus this one. Plus or minus 1 by root 3, 1 by root 3, 1 by root 3. So hence we proved that the direction cosine for a vector equally inclined to all the three axes is this. Clear? So these are the set of problems. Now I want you to go through the video one more time to understand how to solve different types of problems.